Welcome back. We're diving into the world of vector databases today. I know a lot of you are interested in this, especially with all the buzz around AI and large language models.
LLMs.
Right, LLMs. Things like ChatGPT, Bard, or Claude.
Yeah, those AI systems that can understand and generate human-like text. It's pretty incredible what they can do.
It is. Writing different creative text formats, translating languages, answering your questions, even if they're open-ended, challenging, or strange.
Exactly. And they do all that by learning from massive amounts of data. But there's a bit of a catch.
Oh, yeah. What's that?
Well, these LLMs have a tendency to hallucinate.
Hallucinate. I've heard that term. So they're basically making things up.
In a way, yeah. They can generate information that sounds plausible but is factually incorrect or even nonsensical. You see, these models are trained on such vast data sets, but they don't necessarily have a deep understanding of the real world or access to up-to-date information.
So they could give you a convincing answer that's completely made up. It's a little unsettling.
It can be, especially if you're relying on the LLM for critical information. One of the sources we looked at had a concerning example. Someone asked ChatGPT how to disable the automatic emergency braking on a Volvo.
Oh, wow.
ChatGPT gave them a set of instructions. Sounded believable, but they were completely made up. There's no such procedure on a Volvo. This is why ensuring the accuracy and reliability of LLMs is so important.
I see your point. So where do vector databases come in? How do they help with this hallucination problem?
Vector databases are specifically designed to store and query something called vector embeddings. Now, think of vector embeddings as numerical representations of data. They capture the meaning and relationships between different pieces of information. It's like translating our language into a language AI can understand.
Okay, so it's not just storing the raw data, it's about capturing the essence of the information. I'm still trying to picture how these embeddings actually work.
Imagine an AI model that's trained on, let's say, millions of images of different types of fruit. It learns to identify the key features of each fruit, the color, the shape, the texture, things like that. Each of these features is then represented as a vector.
A vector.
Right, a series of numbers. These numbers capture the essence of that feature. Similar fruits, like apples and pears, would have similar vectors because they share a lot of the same features.
Ah, I get it. So it's not about matching keywords like apple or pear. It's about understanding the underlying features and similarities.
Exactly, and that's what makes vector databases so powerful for tasks like semantic search, which goes beyond simple keyword matching to understand the intent and meaning behind a search query. For example, if you search for bank, a traditional search engine might just look for that word in a document. But with semantic search, powered by vector embeddings, the system can understand whether you're looking for a financial institution or at the edge of a river, based on the context of your query.
So if I search for Bank of England, the system knows I'm probably not looking for fishing spots.
Precisely. It's all about understanding those nuances of human language and thought, something that traditional databases really struggle with.
This is fascinating stuff. So vector databases are changing how we search for information, and they're also playing a critical role in shaping the future of AI. But how do they actually help with the LLM hallucination problem?
That's where a technique called retrieval augmented generation comes in.
Retrieval augmented generation.
We call it a RAG for short. RAG combines the power of LLMs with the accuracy of vector databases. It's like giving the LLM a fact checker. So instead of relying solely on its internal knowledge, the LLM can access and retrieve relevant information from a vector database to make sure its responses are accurate.
So back to our Volvo example, instead of making up instructions, the LLM could use a vector database to look at the actual Volvo user manual and give the user the right information.
Exactly. That's the power of RAG. It grounds the LLM's responses in factual information, which makes them much more reliable.
This is incredible. So vector databases are not only changing how we search for information, they're also playing a key role in the future of AI.
It's a really exciting time for this technology, and we're only going to see more and more applications as AI continues to develop.
It sounds like we're talking about a pretty fundamental shift here. It's not just about storing data anymore, it's about storing meaning.
That's a great way to put it. And it's that ability to capture meaning that makes vector databases so well suited for working with AI and working with all this unstructured data that's everywhere these days.
Unstructured data. So we're talking about things like text and images and audio, even video, stuff that traditional databases weren't really designed to handle.
Exactly. Think about all the information we generate every day. Social media posts, emails, photos, videos, audio recordings. It's a lot. Traditional databases with their rows and columns were really built for more structured data, like financial transactions or customer records.
Right. They're great for keeping things organized, but not so much for capturing all the nuances of human communication or the complexities of a visual scene.
Exactly. And that's where vector databases really shine. They give us a way to represent this messy, complex world of unstructured data in a way that AI can actually understand and work with.
Okay, so we've talked about how vector databases can improve search and make LLMs more reliable. But what about some real-world applications? Where is this technology making a difference today?
Well, one area where we're seeing a lot of exciting development is in personalization. Think about the recommendations you get on platforms like Netflix, Spotify, or Amazon. A lot of those recommendations are powered by vector databases.
So instead of just showing me the most popular movies or songs, they're actually trying to understand my taste and recommend things I'll specifically enjoy.
Exactly. They analyze your past behavior, your preferences, and use that to suggest things you might like. By understanding your preferences through vector embeddings, these platforms can give you a more personalized experience.
That makes sense. Helps you discover things you might have missed otherwise. What about beyond entertainment and shopping? Are there applications in more, serious fields?
Absolutely. One really promising area is healthcare. Vector databases are being used to analyze medical images, which can help doctors make faster and more accurate diagnoses.
So, for example,
Well, imagine a vector database that's been trained on thousands of X-rays. It could help identify subtle patterns that might indicate the presence of a disease, even in its early stages.
wow, that's pretty incredible. It's like having an AI assistant that can help doctors spot things they might miss.
In a way, yeah. And the potential benefits are huge. Earlier detection of diseases can lead to more effective treatment and better outcomes for patients.
That's amazing. It sounds like vector databases are starting to have an impact in a lot of different areas.
Oh, yeah, and it's only going to accelerate from here. As AI keeps evolving, we're going to see even more creative and impactful applications of vector databases. In fields like finance, education, scientific research, really, the sky's the limit.
So for our listener, it sounds like this is more than just a technical trend. It's a fundamental shift in how we think about and interact with information.
You got it. It's about moving beyond the limitations of those traditional databases and embracing a more intuitive and meaningful way of organizing and understanding data.
And with platforms like Pinecone making it easier than ever to build and deploy vector database applications, the possibilities are really exciting.
I agree. Pinecone's focus on performance, scalability, and ease of use has made it a really popular choice for developers who are building these next-gen AI-powered applications. Their cloud-native architecture and their intuitive tools allow anyone to harness the power of vector databases, even without deep technical expertise.
So they're really trying to democratize access to this technology. That's great.
Absolutely. They've got all sorts of open source resources and educational materials, which are a fantastic way for anyone to get started with vector databases and see what they can do.
It sounds like this is just the beginning of the vector database journey. There's a whole world out there to explore, and the tools and resources are readily available.
So that's right. What's important is to keep learning, keep experimenting, and really push the boundaries of what's possible with this powerful technology.
I think our listeners probably feeling pretty inspired right now, ready to dive in and start building.
I hope so, because the future of AI is being shaped right now, and with vector databases, anyone can be a part of it.
We've covered a lot of ground here. What's the one thing you really want our listener to walk away with from this deep dive?
I think the most important takeaway is this. Vector databases are really bridging the gap between how we humans understand the world and how AI processes information. It's like we're giving AI a way to translate our messy, complex world into a language that it can understand and act upon.
So it's not just about teaching AI to mimic us. It's about giving it the tools to actually understand and interact with the world in a way that aligns with our own thinking.
That's exactly it.
Yeah.
And that opens up so many possibilities for building applications that are smarter, more personalized, and ultimately more human-centered.
That's exciting. What are some of the most exciting kind of future possibilities that you envision for vector databases?
Well, imagine a world where search engines really get what you're looking for, not just matching keywords, but understanding the intent behind your search. Or imagine chatbots that can give you really accurate information. drawing from a vast database of knowledge, but without those hallucinations we talked about.
Right, yeah. It's like instead of talking to a machine that's just spitting out canned responses, you're having a real conversation with someone who understands you.
That's a great way to put it.
Yeah.
And it goes beyond just search and chatbots. Vector databases are allowing us to develop AI systems that can help us solve really complex problems.
Mhm.
Understanding the nuances of human language, thought, even contributing to scientific discoveries by finding hidden patterns in data.
It's like we're giving AI a deeper level of intuition, the ability to see things that we might miss, make those connections.
And those connections, those insights, are what's going to drive the next wave of innovation in AI.
So for our listener who's been with us on this journey, what would you say to encourage them to keep exploring this world of vector databases? Where should they start?
Well, the great thing is there are so many resources out there now. Platforms like Pinecone offer open source tools and educational materials that make it super easy to experiment and learn.
We talked about their Jupyter notebooks and those Vercel templates. Those sound like good places to start getting hands-on.
Definitely. Don't be afraid to jump in, get your hands dirty, and see what you can create.
Yeah.
The future of AI is being written right now. And with vector databases, anyone can be a part of it.
It's a really exciting time to be exploring this technology. Thanks for taking us on this deep dive into vector databases. I think our listeners learned a lot.
My pleasure. It's been great talking with you, and I hope everyone listening feels inspired to explore this fascinating field and maybe even help shape the future of AI.